Namaste dear students. Now let us discuss the preparation of hydrogen commercially. So how to prepare the hydrogen commercial method? Okay. How to prepare hydrogen commercially. You can see dear students, the production of hydrogen commercially. Let us see here. When by the hydrolysis of water, we will get hydrogen dear students. So it is a basic method of manufacturing of hydrogen. So when you do a hydrolysis, hydrogen breaks up to give the hydrogen and oxygen gas dear students during electrolysis. But when you add small amount of acid, look at here, when you add small amount of either acid or alkali solution, means either HCl or H2SO4 or NaOH or KOH, it is added to the water to make it as good conductor dear students. When you add small amount of acid as acid or base, water become good conductor. Okay, right? See dear students, so how electrolysis will take place? First, take electrolytic cell which contains water, acidified water or alkali water, aqueous solution. So two electrodes are dipped in the electrolytic cell dear students. These two electrodes are separated by diaphragm. What is the use of diaphragm? Diaphragm can allows only cations through it dear students. So these two platinum electrodes are connected to the battery through outer circuit. Okay, right dear students, see I will show you how it will be connected, right? So one is act as a anode, other one is act as a cathode. If positive electrode, let us say dear students, it is a number positive electrode can be called as anode. What is the name of this one? Positive electrode is known as anode. So this is a number negative electrode. Negative electrode. This blue color platinum electrode I indicate as a negative. Negative means it is a cathode dear students. Positive anode, negative cathode. Dear students, when water dissociate, on supplying electricity, water dissociated gives H plus ions and OH minus ions dear students. So these OH minus moves towards, goes towards anode. So undergoes oxidation, gives oxygen gas. So this H plus ion goes towards cathode, undergoes reduction, gives hydrogen gas. Are understanding or not? Let us see the how will the hydrogen gas will be liberated in this dear students. See here H2O, I took here H2O. H2O dissociated, OH goes towards anode. How the hydrogen is liberated, you can see, right? So let us see the next. By electrolysis of water, what are the, just now we have seen, so in the electrolysis we use Asbestos diagram. When electricity is applied, water breaks into hydrogen and dioxygen. Yes or no? So dear students, what is the reaction takes place in the during the electrolysis of water? So dihydrogen gas is collected at cathode. Yes or no? Just now you have seen, dioxygen at anode. H2O dissociated gives H plus and OH minus, H plus reduced to H2 gas at a cathode, OH minus oxidized to oxygen at anode. We have seen. So this is a electrolysis reaction of water dear students, right? So next, to get the pure 199.95% of pure H2 gas. So by electrolysis of warm aqueous barium hydroxide dear students, when you do warm aqueous barium hydroxide solution, you will get 99.95% of hydrogen dear students. But instead of platinum here we use nickel catalyst. Okay. Next, electrolysis of brine solution. Brine solution means aqueous solution of sodium chloride is known as brine solution. What is a brine solution? Aqueous solution of sodium chloride is known as brine solution. Aqueous sodium chloride in the brine solution. See dear students, when you do electrolysis, first in this hydrogen gas obtained as a byproduct dear students in the manufacture of sodium hydroxide and chlorine. So it is an industrial process for the electrolysis of sodium chloride. Hydrogen is obtained as a byproduct in the manufacture of sodium chloride and sodium hydroxide. See dear students, in this we take a electrolytic cell which contains brine solution. Brine means sodium chloride solution. Aqueous sodium chloride solution is called brine solution. Two electrodes are dipped in this electrolytic cell. One is act as a cathode, one is act as an anode. Anode and cathode. What is the sign of anode? Positive. What is the sign of cathode? Negative. Sign of cathode is negative. Sign of anode is positive, dear students. You can see here, right? Next, see, dear students, these two electrodes are connected to the battery. Okay, so when you do electrolysis, so what are the ions are there in the solution? Do you know, dear students? So I will show you here. Let us see, dear students. So when you do electrolysis at cathode, hydrogen gas is liberated. You can see the reaction also, dear students, at the side. You can see here. So sodium aqueous NaCl having NaCl as well as water. NaCl dissociated gives Na plus and Cl minus, dear students. H2O dissociated breaks up gives H plus and OH minus. At anode, chloride, so here two anions are there, dear students, Cl minus and OH minus, which has more discharge potential. Chloride has more discharge potential. So chloride oxidized to chlorine gas at anode. So at anode, chlorine gas will be liberated, dear students. At anode, chlorine gas will be liberated. At cathode, two cations are there in the aqueous solution, Na plus and H plus. H plus has more discharge potential than Na plus. So H plus goes to cathode and it reduces to hydrogen gas, dear students. At cathode, hydrogen gas will be liberated. So what is left out in the solution? Only Na plus and OH minus are left out, dear students, in the solution. Yes or no? So these Na plus and OH minus combined, it can use the NaOH solution. So what is left out in the solution? In the vessel, NaOH is left out, dear students. So in the manufacture of sodium hydroxide and chlorine gas, hydrogen gas obtained as a byproduct in the electrolysis reactions. Electrolysis of aqueous NaCl or brine solution. Okay, I hope you understand, dear students, about this. Let us see. So how hydrogen gas is liberated are you seeing, right? Hydrogen as well as chlorine. It is a chlorine gas. This is a hydrogen gas. See, dear students, how reaction takes place in the during the electrolysis of hydrogen. At anode, just now I told you, two chlorines by gaining of electrons converted into Cl2. By loss of electrons gives Cl2. So if we take two Cls, it loses 2 electrons. At cathode, hydrogen by gaining 2 electrons, it converted into H2 gas, dear students. I told you H2O it dissociated gives H plus and OH minus, right, dear students. So overall reaction, how to write here? Na plus and 2Cl minus plus H2O converted into Cl2 gas, H2 plus NaOH. N2Na plus OH and NaOH. Okay, I hope you understand, dear students. During the electrolysis of water, acid or alcohol is added to make good conductor of water. Good semiconductor of water, insulator. Which is the correct answer? Good conductor of water. Okay, we have seen, dear students. Let us see one more example. During electrolysis of brine solution, dihydrogen is obtained as a main product, byproduct, or both, and none of this. Just now we have seen as a byproduct it will be formed. Okay, I hope you understand, dear students, clearly to all. So next let us discuss commercial preparation of hydrogen by part 2. Are understanding our, dear students? Okay. Now let us discuss commercial preparation of hydrogen. Commercial preparation of hydrogen, second part. Okay, thank you, dear students.